All right, so if you have a textbook and you feel like it, the hardcover, the ones you have under your desk, it's on page 266. Again, everything will be on the board, so you don't need to have it out. If you want to put it away and get it out of the way, that's fine. Chapter 6.3, linear functions. Your online textbook, I think it's chapter 7.3 in the blue one. I don't know, but it's titled linear functions. Okay. Today we're only going to be using slope-intercept form. I don't care that you know what that is, just know what it looks like. Slope-intercept form is an equation in the form of y equals mx plus b. So what we did yesterday and the day before is we started with an equation and you were asked to create an input-output table and then you were asked to graph it. Today we're going to work backwards. We're going to start with a graph or a table and we're going to work backwards to the equation. We need to be able to work both ways. To get to the equation, it's a little more complicated than it's about the same complicated. It's just different. You can't do it the same way we did working forwards. All right. To get an equation in slope-intercept form, you need two things. You need this thing called M and this thing called B. M represents, anybody know? Nope. B represents, nice, if you look into the book, smart girl, Y-Intercept. All right, we're gonna have to find both of these today. We're gonna find them in a graph and in a table. We're gonna use them to write our equation. Just so you know, this is called slope intercept. Again, you don't need to know this. We'll do slope. We'll spend an entire couple days doing only slope intercept form. That'll be later on. This y equals mx plus b, that is slope intercept form. There's three forms of an equation we'll do this year: slope-intercept form, point-slope form, and standard form. This is the most common of the three forms that we write an equation. It's the easiest to do, in my opinion. Okay, so we need to find slope, we need to find the y-intercept. Now slope can be represented as the change in y over the change in x. This little triangle is a symbol that you probably have seen before but didn't know what it meant. This is, I think, the Greek symbol delta. It's been a long time since I took Greek, but I think alpha looks like this. Beta looks like this. And then delta is that. So they're just Greek letters, basically. We use them in math all the time. Like theta. You guys seen theta before? Yeah, theta is just a Greek letter for the sound, I think. I don't know. It's been a long time since I took Greek. But we use theta a lot. Yeah. We've seen lambda before. Lambda is like a cursive L. Okay, anyways. Delta is a symbol that represents change in. So basically what we're doing is the slope of a line is represented by the change in the y variable divided by the change in the x variable. Now this doesn't make sense to you, and it doesn't need to. The thing we care about is the formula that is based off of this. Now if I start at 30 and I go to 100, how much have I changed? 70. And calculation-wise, how did you find that? You did subtraction. 100 minus 30 gave us 70, right? Well, that's how we find the change in y. We take our second y coordinate. We call this y sub 2. It's a little 2 to the bottom right. we subtract our first y coordinate, y sub 1, and we divide that by our second x coordinate minus our first x coordinate. Now these little numbers you haven't really seen before, but they're called subscript. So what does this mean? Yeah.
Y times itself.
Y times itself, or y squared, right? If I move this 2 down here, it's not the same thing. This just means the position of that y in a list. So think of it like this. This would be the first y, second y, third y, fourth y. It's just the position in the list. That's called subscript, S-U-B, like a submarine. What? Oh, did you? Good, yeah. Lots of stuff uses subscript. Yeah. Especially, I think chemistry uses it, right? Is that what you're using in science, chemistry? Like H2O, the little 2's in the bottom. I don't know, does that mean something? Doesn't that mean there's 2 hydrogens? Well, in math, it's like, it doesn't mean there's 2 of them. Well, it does. It means there's another y coordinate, right? So the first and second y coordinate. Yeah. Okay, so this has a name. It is called the slope formula. And this is the formula we use to find the slope of a line. And you might be kind of like, why do I care what the slope of a line is? Well, in mathematics, the slope is the rate of change. So you remember when we were doing the tables a couple days ago and you were noticing patterns in the table? Like you would know as x goes up by 1, y was increasing by 2. Remember that? Yeah. Well, those patterns are the slope of that function. It's the rate that the function is changing. Now visually, we can see a slope by how steep the line is. This slope is steeper than this slope. In a table, we can tell the slope by how fast the points are changing. As an equation, we can quickly identify the slope as the coefficient of the independent variable. All right. So we're going to use this. Now, the y-intercept. The y-intercept is b, and it is the y, it's the output when the input is 0. So it's that second number in the ordered pair when the input is 0. And we call it the y-intercept because it's the point where the line crosses the y-axis on a coordinate plane. So the y-intercept here is 0 because it crosses the y-axis at 0. If this line moved up to here, my y-intercept would be 30 because it crosses the y-axis at 30. Okay, now I've just given you a ton of information. Doesn't make much sense yet because I haven't showed you how to use it. So I'm going to show you how we actually use this information. Am I moving too fast? Yep. Okay. So we are going to write a function rule. What's another name for function rule? Thank you. We're going to write an equation for the following graph. I'm just going to sketch this graph. You can do the same in your notes. It doesn't have to be perfect because we're going to write down the ordered pairs anyways. So here's our graph. Honestly, it doesn't have to be perfect. You just have to have a line with these three ordered pairs on it. And just label the ordered pairs. -3, 2, 0, 1, and 3, 0. Yes? On the x-axis?
No, so the y-intercept is like when it goes
Through the y-axis. Could the line be below the x-axis across in the negatives, you mean?
Yeah.
Yes. Yeah. And in fact, it often does. Okay, so we have a graph, and we want to work backwards from what we were doing earlier this week. We want to start with the graph and get to the equation. So the first thing you should really do is write down the general format of the equation, how the equation is going to be written. And we do that like this. And this tells us the things we need for our equation. Now y and x, those are our dependent and independent variables. And depending where we are on the line, your inputs and outputs are going to be different. These stay variables. It is the m and the b that we need to find. It is the slope and the y-intercept of this graph that we need to find. So the first thing you find, which you don't have to do it first, but the first thing I'll look at is the y-intercept because it's very obvious what it is. So what is the y-intercept of this function? Gabby? 1. Why is it not 0, 1? Correct. Only interested in the y value when x is 0. Okay. All right, so we've got our y-intercept. It's done. We can see it right here. This is our y-intercept. And we're only interested in the y value of that intercept. Okay, so now we need to find the slope. And this is going to take some effort. We're going to use this formula to find our slope. So the first thing you want to do when finding your slope is write down the formula. Now we need some values to plug into that formula. So we need to identify values that we want to use in that formula. So what we're looking for is we're looking for a y, an x, and an x. How many points does this make us think we're looking at? 2. You only need 2 points to find the slope of a line. How many points do I have labeled on this line? 3. So we get to pick any 2 points we want. Generally, you want to use the ones with zeros because they're easier to calculate with, but I don't want to make it too easy for you. So let's use this point here and this point here. So we've picked the 2 points we want. Now here's what you're going to do. Let's write those points down. And what you're going to do is you're going to decide which point is first and which point is second. It doesn't matter which, but you need to designate one of these points as the first ordered pair and one as the second ordered pair. So what I do is I literally write, right next to them, I write first, second. This helps me remember which point is which. You don't have to do that, but if you don't do that, you will mix up your coordinates and mess up the calculation. So if this is my first coordinate, 3, 0, what is 3? This is my first x. What's your name? Filbert. What is 0? Y1. Good. So if 3 is x1 and 0 is y1, what is negative 3 here? X2. And the 2 here is my second y. So by labeling these, you're not going to mess up when you plug them into the formula. If you don't label them, you probably will mess up in the beginning. Eventually, you'll be able to do the slope formula pretty much in your head, but for the next month or so, I'd recommend, well, we are going to be writing it down each time. Okay. So pay close attention to what I do here, because this is kind of where people screw it up. I'm going to take these and I'm going to replace them with those 4 numbers. Watch how I do this. I draw my line. I draw parentheses minus parentheses. Parentheses minus parentheses. These subtractions, they come from this formula here. So I move the subtractions over. In the parentheses are where these 4 numbers are going to go. So which is my number for y sub 2?
2.
You can just say it, guys.
2.
So I put a 2 there. What's my number for y sub 1? What's my number for x sub 2? And my number for x sub 1? Okay. Now, my previous 2 mods that I taught this to, one of the mistakes they made was they might have accidentally put this 0 here and this negative 3 there. And it'll look like you're still doing it correctly, but you'll actually end up with the wrong slope. So be very careful when you place these numbers in here. Another thing they did is they accidentally put the 2 x's on top and the 2 y's on the bottom. Alright, so now we calculate. 2 minus 0 is 2. And negative 3 minus 3 is negative 6. So when you find this is your slope. When you find your slope, you want to simplify it or reduce the fraction if you can. You never want this to be a mixed number. You always want it to be either a proper or an improper fraction. So what is 2 over negative 6 equal?
1 over -3.
Okay, negative 1/3. Now here's the thing. If the denominator is negative, you can pull that negative out front, because a positive divided by a negative is a negative. If the numerator is negative, you can pull that negative out front, because a negative divided by a positive is a negative. If they're both negative, 2 negatives cancel out and they become positive. So you just cross them out. If they're both positive, it's obviously positive. Okay? So only when one of them is negative is the whole thing negative. There's my slope. So I'm going to plug that in here. This is my equation. Yeah, there's a lot of stuff to do, but it's not like it's the hardest stuff to do, right? Now the good news is, eventually we're going to do slope-intercept form, and you'll be able to we won't be doing all this slope formula stuff. You'll be able to, there's a faster way to do it. But this is the mathematical way that we need to learn first, because this helps us understand slope better. The fast way is like a shortcut. And it doesn't tell you much about why we're finding slope. All right. So what does negative 1/3 mean in terms of this line? It means every time we go down 1, the x increases by 3. We go down 1, the x increases by 3. This is how fast the line is decreasing. If we were positive slope, every time the x changes by 1, the y is increasing by a certain amount. That's from a graph. Any questions? None about any of this. We don't have a lot of confidence. Okay. Example 2, and this will be the only one. This will be it. After I'm done with this, we'll do a practice. Now we're going to write a function rule for the table. So on the last problem, what's like the very first thing we found? So finish writing the table, and on the last problem, on that graph, what's the first thing we found? So look back to example 1. Yep, Shemai? The y-intercept. The y-intercept can be found first, or we can do it after its slope. But generally, it's the easier one, so we just get it out of the way. So looking at this table, can anybody tell me what my y-intercept is? Yes?
4.
And how do you know that it's 4?
Because the x-axis is 0.
Good, this is your y-intercept. Because the y-intercept is when x equals 0. So boom, we're done with the x-intercept, or the y-intercept. And remember, we're only worried about the y value. Yeah, Jonah. You good? Okay, so now we need to find what? Jerry?
The slope.
Slope. And what do we use in order to find the slope?
Slope intercept
This is slope-intercept form.
formula. Slope formula.
Slope-intercept formula, or the slope formula, yeah. M equals okay, now we've got the formula written down. How many points do we need to use? 2. Now, how many points are in this table? 4. We only need 2 of them. You can use the y-intercept as a point, it's fine. Does anyone have one they want to use? I don't know. Jarrett or Shemaiah, which one looks the most difficult to use? You said this top one? 2-8, and what else? Okay, we'll use those 2 points. It doesn't matter which 2 we use. What does matter is that we label them. So Shemaiah, which one do you want to make the first point? So let's make this our first coordinate. And let's make this one our second, is that what you're saying?
Yeah.
Okay. So if negative 1, 2 is our first coordinate, what is negative 1? x1,
Oh my gosh,
x1, or x sub 1. So if this is x sub 1, what is 2 here? And this 2, and this 8. Now again, you don't have to label them, but I'm telling you guys, label them. Label them at least for a while, until you get the hang of this. Alright, so we've got our things. Let's plug them into the formula. What is y2? What is y1? What is x2? What is x1? Okay, there's our calculation we need to do. All right, 8 minus 2 is simple, that's 6. What is 2 minus negative 1? Who knows? Say it, you can say it. 3? Why is it 3? Why is it not 1? Why is it not negative 1?
Plus a negative. Because a negative next to a negative sign automatically becomes a positive.
Uh-huh. So it becomes 2 plus 1, right? Yeah. Is anyone fuzzy about that? Do you want me to show you? I can explain it in a way that might make more sense. So I see a few heads nodding. If you've got a number line, and we're doing 2 minus negative 1, right? So if we're doing 2 minus negative 1, here's 2. When we subtract, which way do we go? That way. But that's when we subtract a positive. Like 2 minus 1 would be 1 this way, right? So if we're subtracting a negative, we start going this direction, but really we have to turn around because it's a negative and go that way. So subtracting a negative, we're actually moving to the right, 1 spot. Okay? Did that help? Or make it worse? Hopefully it helped. All right, so that's 3. And 6 over 3 simplifies to what? 2 over 1. So we can write our slope 2 different ways. Just a heads up, we like fractions as our slopes because later on we're going to talk about something called rise over run, so fractions are good. But it doesn't have to be a fraction, so we can write our slope as 2 over 1, or it could just be 2. Okay. Questions? Can somebody summarize this entire process for me in your own words? You can use this as an example. Shemaya, then we'll talk to Gabby, then we'll talk to Jonah. Go.
So, first
Speak loudly so I can hear you, everyone can hear you, and the camera can hear you.
okay, so first you have to find the Y-intercept, which is B, and then after that you have to figure out what's your first and second, sets, and then after that you have to figure out which one is x1, x2, y2, y1, and then after that what you do is you plug it into the formula for m, which is the slope. And then after that, you subtract y2 and y1 and then x2 and x1. And then after that, you simplify the fraction that you get. And if it's possible for it to be a whole number, then you can do that as well. And then you plug it into the y formula.
Yes.
Y equals x plus b.
Perfect. All right, Gabby, would you like to add? Did she cover it? Jonah? You want to add? The slope is defining rate of change, right? Yeah, exactly. Okay, good. All right, let's stop this thing.